All right, everybody. I guess we're ready to start then. Um, first topic discussion is what exactly is Leetcode? So, Leetcode is kind of a website that you can use to practice your ability to solve problems that deal with certain algorithms. So, it's important for getting hired at companies that you study Leetcode problems, and they cover a variety of topics. So, I can show you here the main topics that are used are array and hashing, two-pointer, sliding window, stack, binary search, linked list, trees, heap plus priority queue, backtracking, graphs, advanced graphs, 1D dynamic programming, 2D dynamic programming, greedy, intervals, math and geometry, and bit manipulation. Um, since most of you are still in high school, we're going to stick with some basic problems like array and hashing, and two-pointer. So first, starting off with valid palindrome. So a phrase is a palindrome if after converting all uppercase letters as lowercase letters and removing all non-alphanumeric characters, it reads the same forward and backward. Alphanumeric characters include letters and numbers. So given a string S, return true if it is a palindrome or false otherwise. So input, a man, a plan, a canal, Panama. So this is true because we got rid of all spaces and just had the letters. Because this is what happens when we process it to get rid of all spaces. Just if we get rid of all things that are not letters. So the way to solve this is essentially to use two pointers. So the benefit of using two pointers is that we can essentially do this in O of n divided by 2 time. And the reason that's O of n divided by 2 time is that O of n is that when you're O of n, which is essentially a way to define time complexity or how long a function takes to run. So O of n would be if we went through the entire string, so the entire string S. But if we use two pointers, we have one pointer that comes in from the left, one pointer that comes in from the right. So the left one increases by 1, right one increases by 1. Essentially, it's comparing. So what I mean by two pointers is that one pointer starts here, another pointer starts here, and they slowly move inwards. And while they're moving inwards, they're comparing with the other pointer. So the first thing we need to do for this problem is to get rid of all the non-alphanumeric characters. So we can use this using the RE library. So the RE library essentially is just regex. So regex is looking for certain patterns and replacing them. So we're gonna set S something new. So we're gonna do re.sub. re.sub is calling the RE library, getting the sub function, and now what we want to do is we want to get rid of all the non-alphanumeric characters. So to do that, we would do r dash w dash w space plus and then replace it with nothing. And our input is s dot lower, right? So has to replace that. Yeah, sounds about right. Next, what we have to do is we have to have a for loop that essentially goes halfway through S. And halfway is because we have two pointers that are coming in from both directions. So for I in range len S divided by 2, if Si does not equal S length S minus I minus 1, return false or return true. So what we're doing is that we're going halfway through the string. So we're coming in from SI is coming in from this side, and s length I minus 1 is coming in from this side. So the reason is that we're doing x length minus I minus 1, not just s length minus I, is that length gives the length of the string, not the number of elements, right? So the way would we number in programming is that we have the first element is 0, second one is 1, second one is 2. But if we just did length s and got the index for that, we get an index out of bounds error, because everything is starts from the 0th position. So if we run this, it should work. Accepted. Yes. So these are all answers from way back in May. But if we look at the statistics for the runtime and the memory, memory not so good, but it's not a big deal. But the runtime was very fast. It beat 92.81% of all other runs. Next, we have group anagrams. So for group anagrams and these other 4 pods that we're doing, we're going to need a special type of data structure called a hash map. So a hash map, what does that exactly look like? So a hash map has key value pairs. So it looks like this. Key 1, key 2, key 3, key 4. So if you inserted the keys key 1, you'd get the value Java. You inserted the value key 2, you get the value C++. And in Python, we call them dictionaries because when you're going through dictionary, right, you have the key, which is the word, right? And you get the output, which is the value, which is the definition, right? So dictionaries in Python kind of look like this. To define them, you use the curly brackets. So right here, Jack is the key, and his value is 4098. Sape is the key, and its value is 4139. And to access, to change some of them, or to like add, you would do tell Guido 4127. That adds a new key value pair. So if you print it, it looks like this. Now, if you want to access the value, you give the key, which is in this instance is Jack, and you get 4098. You can delete key value pairs. And this is another case of adding it, converting it to a list. So this gets rid of all the values and only has the keys. And you can also sort that, but this is not really related to dictionaries. So moving on to group anagrams. Given an array of strings, group the anagrams together. You can return the answer in any order. So an anagram is a word or phrase formed by rearranging the letters of a different word or phrase, typically using all the original letters exactly once. So stirs, eat, tea, tan, ate, nat, bat, which becomes bat, nat, tan, ate, eat, tea. So I'm thinking a good way to solve this is we have a key value pair. So the key has to stay constant among the groupings. So in this instance, it's probably going to be the sorted string of the anagrams. So for eat, tea, and 8, it would basically be whatever. If we sorted eat by alphabetical order, that would be the key, and the values would be a list of the value of the anagrams. So first thing I want to do is that I want to put the strings into a hash map as a list. So I would define a hash map called A, and I would define it by having it empty by doing the curly brackets. So then I would iterate through each string in the parameter strs, so strings, and I would set the key equal to in alphabetical order, essentially, of the letter of the word of S. So I would do dot join sorted S. So what this is doing is that it's creating this sorted S returns an array, which is why we have to do the dot join function to convert it into a string. So essentially what we're doing now is if key is in A, so we're checking if the sorted anagram is in A, which means something like that has already been found. You would do a key to get the value, and we would append S because the key value pair, so the key is a string, the value is a list. Else, you would do, if it has not been found, if the anagram of it has not been found before, we'll set a key equal to S. So we'll put S in a string. Well, the thing is, we want a list, so we have to extract it next. So B is equal to a list. For key in A, B dot append A dot key. So what this is doing is that it's creating a new list because we have to our output has to be a list. So we're going through each key in the hash map. So this is how you iterate through it. And we're appending the values. And how we access the values that we use a key. And then we return B. And this should work. So you can see it passed all the sample test cases. And if we submit it, it should work. And let's look at, so you can see memory and runtime were very good. It beat about 88% of all submissions, which is good. Yeah. So next, let's do contain duplicates. So this will probably also have to use a hash map for speed purposes. But I want to give you guys an example, a very intuitive solution that might not be fast. So one way would be to do it is to have like a nested for loop. So we go through each list. We start with 1. Then we add another for loop that goes inside of that for loop that goes 2, 3, and 1, right? And that way it's very easy to find if there's any duplicates. So for that, we would do for I in range length nums. And then we do, then we would do a nested for loop for j in range I. If nums I is equal to j. Yeah. So what this is doing, it's starting at and 1. So this is doing this, it's doing a nested for loop. So as an example, for I in range like nums, say here we started at 1, right? And then the next for loop would go through everything starting from I, actually I plus 1, going till the end of the string and incrementing by 1. And if they are equal, return true, which means the duplicate has been found. It's nums. So you see that that led to some errors. So you don't want to use a. Oh, actually, this is wrong. This should. Yeah. So that didn't work. So you don't want to use a nested for loop. Okay. What you do want to do is use another hash map to count the instances of a certain of finding the instances of if you had found. So for this new hash map, the key value pairs would be the key would be the actual number, and the value would be how many times it had been found. So no, turn true. So what this is doing is that we're creating a hash map, right? Oops, that's needs to be there. Creating a hash map. So the key is the actual number, and the value is how many times it's been found. So the benefit of a hash map is that accessing the variables is very fast. It's almost O of 1, which is better than an array. So if I run this, it should work. I forgot this, yeah. And look, it works. So we use a hash map for this problem. And look at that. Yeah, B63, B72%, which is good. Now let's do two sum, which is very easy problem. Okay. So, given an array of integers, nums, and integer target, return indices of the two numbers that they add up to the target. You may assume each input should have exactly one solution, and you may not use the same element twice. You may return the answer in any order. Okay. Oh, I'm thinking there's one intuitive way to solve this. I think I'm going to do a nested for loop, and hopefully that would work. But actually, maybe let's not try that, because the problem with nested for loop is that it takes up a lot of time, right? Because at maximum, it's O of n squared, because you're going through two strings, right? So you have the outer string, which is the outer loop, and you have the inner string, which is the inner loop. And when you have like a nested for loop, you multiply it, so it becomes O of n. O of n squared, which is just too slow. We want something that's O of n, so we should probably use a hash map. So let me define a hash map. And let's go and go through the numbers. And what we want to have as the key value pair, the key should probably be the key should probably be the integer that we're looking for, and the value should be the index. So as we're going through each list, so say our target is 9, right? Well, you can't have anything that's adding up to this, because we've just gone to the first. This is the first element, so we add it to our hash map. So 2 is going to be the key, and the index is going to be 0. And when we get to 7, we want to find 9 minus 7. So we look for the key that's 9 minus 7, which is 2. So return 0, which is the value of key 2. Return 1, which is the value of key 7. So that's what we do if target minus nums on in nums, or I should say not nums, in h1 m1, return h1 m1 target minus nums on and I, else hm1 to nums I. So we're going through the list, and we're finding if the current element target minus stat exists in the hash map as a key. And if it doesn't exist, we return the value of that key that was found and the index of the current element. And if not, we add we create a new key value pair. So we add the current element and we set its value equal to the index. So this should work. Same error again. And wow, look, that worked very well. If we submit it, it should work too again. And look at that. So it beat 97% for runtime and beat 92% for memory, which is really good. Now let's do valid anagram. So given two strings s and t, return true if t is an anagram of s and false otherwise. So anagram is a word or phrase formed by rearranging the letters of a different word or phrase, typically using all the original letters exactly once. So I think for this problem, we should also use a hash map. So let's actually use a hash map for each of the strings s and t. So essentially what we're going to do is that we're going to populate these hash maps with keys being the actual characters and the values being how many times they appear. And at the end, we compare them, and the comparison function is only of one time, which means it's constant time, which means it's very fast. So let's go for I in range length s. Oops, that's lowercase s. If s I, so if the character at that index is in the hash map as a key, hash map, we're gonna access the value, and we're gonna do whatever it is plus one, right? And if it's not there, if the character is not there as a key, we're just gonna set the value equal to one because it's been found once. And we're gonna do the exact same thing for HN2. And now we have similar formats for each of them. All we have to do is if the HN hash map 1 is equal to hash map 2, return true or return false. And this should work. Oops, might have messed up something. Oh, this. Yes. Don't know why I'm using the exact same one. That was an accident. Now it should work. And it does. Wow. Amazing. And if we submit that, it'll also work. But there's one problem. We have two hash maps. Maybe it's a good idea to use only one hash map. The benefit of that is that it won't decrease, the C solution won't decrease the runtime, but it will use less memory. So to use one hash map, what we could do is that we could iterate through S, and then populate it based on the key being the character and the value being how many times it appears in the string, and then we iterate through the second string, and what we do is that whenever we find that character, we minus the value by 1 for the key, and essentially what we should have is an empty hash map. So that would use less memory, and I'm going to display how to do that right now. I need to make this. So we're going to populate the hash map. So then we're going to do tj is in hash map 1. Then hm1 tj is equal to hm1 tj minus 1. So if hm1 tj is equal to 0, we delete hm1 tj. So we're gonna get rid of that key value pair. We're gonna get rid of that key value pair, and then we're gonna turn false if that's not true, which means they're not anagrams. So if not hm1, which means if it's empty, right? We return true. Else return false. So the difference between this false right here and this false right here, this false means that the character in the second anagram is not, the character in the first string is not in the second string. And this one right here means that the second string had less characters, which means the first string still, the hm1 still has something left inside of it. So this should also work. Oops, might miss something up. I have to find the error. Oh, this is the error. Okay. That right there, what it was before was an equality statement. It should be an equal statement. And now it should run correctly. There we go. And it was correct. It is a little bit slower. Actually, it shouldn't be slower, actually. The reason being is that the first solution that I gave was O2n. This is also O2n. And what I mean by O2n is that there's two for loops that are O of n. So when they're not nested and when they're like this, it becomes O of n plus O of n, which is O of 2 of n. And if we submit it, it should work. And use less memory too. And there we go. So memory, be 16%. That's not a big deal. Runtime, be 66%, which is also really good. And yeah. So I think that's it for today. Thank you guys all for coming to my Leetcode session. I know we only did 5 problems, but this is basically to motivate you guys to solve these problems because it's very important to getting a job. And the truth is that these problems are really not that hard. At least the easy ones are not that hard. But once you get to about 80 to 90 Leetcode problems, a lot of it comes like rote memory, and they all have the same patterns, the same algorithms to solve them. So I hope this inspires you guys to solve Leetcode problems. And yeah, Leetcode is very important for getting a job. So that's it. Thank you all for coming, and I hope you all have a nice day.